Hello, welcome to the channel, guys. Particularly, welcome to the course of TCP/IP. Today, we are going to discuss about a new concept in IPv6 and this IPv6 transition. As you know, there are three methods are available, guys: dual stack, tunneling, and header translation. So let's take why there is IP translation is required and how it happens. So here in the first slide, what we have basics how to read an IP version 6 address. Because the most important skill in IP version 6 transition is simply understanding how to read an IP version 6 address, because the IPv6 address are so much larger compared to the IP version 4. They use a different method to break each number down so it's more manageable. If I say it is more larger, so it is 4 times larger than the IP version 4. IP version 4 is what 32 bit and the IPv6 is what 128 bit. Okay, and this this 128 bits are again divided into different parts, like the notations are different, octets and the decimal portions are very different. So each 28 bit address is broken down into the 8 group of 16 bits. So one group is having 16 bits. Likewise, this is our total 8 groups are available that are represented in hexadecimal format also. The format can be again mixed, hexadecimal plus numbers also there. The 8 group are separated by the colon. So this is what the colon is available. Now, for example, if we see this 201.0048, likewise, this is what the address available. So this address is usable, but it is still fairly large to work with. So we can do better than this. So what we can do on we can apply some methodology on this address, and we can reduce this address so that it can be easily readable. So for example, within a each 16-bit segment, any leading zero can be eliminated from the address. So what we have discussed earlier, the zero compression method, where the contiguous zeros are available, that can be eliminated by the colon also. Okay, so this consecutive eight times zeros are available. It means what there is a only values available is what zero. We can compress it with the this colon 0:0. So we have compressed it. And one more last trick, we can fully condense this IP version 6 address. We can eliminate one more consecutive 16-bit group that contained all zero. So in our example, the fully condensed IP version 6 end up with the looking like this. Let's say here we have added 2 colon. Here we have added 2 colon. So this is what the very fairly condensed form of that IP version 6 and reduced form of IP version 6. So in this way, we can apply the different methodologies over this. But this is not all suitable, guys, because we have to apply this technology internally so that that network or that host can understand the addresses easily. Because nowadays, many of the people are using IP version 4, some of the using an IP version 6. So it is a dicey situation where how that the addresses can be translated. So here there is a translation, transition, interoperation from the IP version 4 to 6. There are three alternative names: translation, transition, interoperation. Okay, so once we have a grasp of the basic regarding the IP version 6 addressing, the next step is to understanding the different implementation approaches we can take to get the IP version 4 and 6 routing to operate either independently, side by side, or in tandem nature. So these are the three methodology we can see. We can operate on this either independently, side by side, or maybe a tandem. Okay, and for this purpose, what we have three strategy have been devised. Very first strategy is what the dual stack. Second will be tunneling. Third will be header translation, each with having the separate existence. So what do you mean by dual stack? It is recommended to all those they should have both protocols. Tunneling, if middle having the IP version 4, so that region must have IP version 4 header for encapsulation, and both end having the IP version 6, but IP version 4 is between. We can say directly. Header translation, if the receiver having IP version 4, and then it tunneling cannot be worked. So what we have to do, we have to translate that header. So we'll take the three method individually. This only one sentence is available. What is the available with the dual stack, tunneling, and the header translation? Let's take one by one separately. Now, here, dual stack. It is recommended that all the hosts before migrating completely to version 6, have a dual stack protocol. Nowadays, many of the computers are still using the IP version 4. And if the service provider is, let's say, we having IP version 6, so it is recommended to that all the hosts available on the internet, that they must present both type of dual stack so that they can understand IP version 4 as well as the IP version 6. In the other word, the station must run IP version 4 and IP version 6 simultaneously until all the internet uses IP version 6, because we still we cannot still say that the totally internet totally is work on the IP version 6. There are many of the reasons and many of the portions are available where the IP version 4 is again using. Okay, this figure shows the dual stack mechanism. To determine which version to be used sending packets to destination, the source host queries the DNS. Okay, if DNS return the IP version 4 address, then source must send the packet in IP version 4. What it how it can be analyzed? Then what we have the field base header, and the header format is available packet format, where the very first field is what the version field. Very first field is what the version field. On the basis of this version field, let's say if the value is 00, let's say 00, this is what the 0. If I want to, let's say 4, so 1, 2 and 4, so value will be, let's say 0, 1, 0, 0, it will be 4, so version 4 will be acting. If the value is, let's say 0, 1, 1, 0, then version 6 will be acting. So it depends upon what this version field. And if the DNS return the IP version 6 address, this source host send the IP version 6 packets. So it depends upon what DNS that domain name system resolve that particular field. So on the basis of that, that particular packet format and that particular packet format will be encapsulated and the message will be sent. So how it is going to happen? Let's say to use the IP version 4.6 version 4 system, here the both the stacks are available. Let's consider this is what the system where IP version 4 and IP version 6 both the stacks are available. If on the basis of DNS or any recognition mechanism, it has been recognized that the version 4 is there, so version 4 stack will be maintained, and second will be if we recognize on the 6, so version 6 will be maintained. Here at the transport layer, applications can be work on that particular versions. Then here at the bottom end, what we have LAN and WAN technology. So what dual stack mechanism? Dual stack mechanism is what? Instead of uh, maintaining only one stack, what we have proposed to do, what we have to maintain both the stacks so that any kind of query can come. And in order to understand any kind of query, that the version 4 and version 6, we will be in the position to understand, and our packets or datagrams can be transferred from one end to another end. This is what the dual stack mechanism guys. Let's take the second one, that is tunneling. What the tunneling meaning? Tunneling is the strategy used when two computers using IP version 6 wants to communicate with each other, and the packet must passes through the region that uses the version 4. Okay, so here both the ends are IP version 6, but the in between portion is what the IP version 4. What we have over here, to pass through these regions, the packet must have IP version 4 address. So IP version 6 packet must be is encapsulated in IP version 4 packet. Then it enter into the region and it leaves its capsule, or let's say information, when it exits this region. It seems it seems as if IP version 6 packet goes through a tunnel at one end and emerge at the other end. To make it clear, IP version 4 packet is carrying an IP version 6 packet as data. The protocol value is set to be 41. So what do you mean by tunneling, guys? So here the host is using the IP version 6, that is what it says sender, and receiver is also using the IP version 6, that is what the receiver. But the reason in between this particular two computers or two ends, what we have the entire network is of what the, let's say, IP version 4. So what happened if I'm sending the packets with the IP version 6? So the fields are different, because in IP version 6, what we have 8 fields, in IP version 4, what we have 13, 14 fields. So that need to be matched. So what happened? So let's say in host to router, this will be transfer as it is 6 to 6, but this router once comes into the router, then router to the next hop, there is a region of what? IP version 4 region. So what we have to do, we have to uh, uh, we have to add our mechanism. What mechanism? IP version 4 mechanism. So here there is a payload, that is message is available. On the message, it was what earlierly IP version 6 was added. Now here in this region, what we have to add? We have to add the IP version 4 header. And the best example to this is what we are sending the letter. We are sending the letter from our hand. We are going to the courier. Courier one added some kind of additional information, because that information can be understood by the courier agency. So this is what the best example. Second example, I can show what we have: the very large truck available with us. That truck carrying a kind of kind of cars, middle kind of truck, let's say. On that truck also there are some bikes are available. So bikes, then middle truck, and the large truck. So carrying container, then container, and then the bikes. So this kind of mechanism is available. So here automatically we have to add both the things. And tunneling is what a kind of logical way, logical path through which the datagram can be passed. So this is what the tunneling, guys, where the both the end having the 6, but the region which is middle region is what the IP 4. Then the third methodology is what the header translation. The header translation is necessary when the majority of internet has moved to the 6, but some systems still uses IP version 4. Nowadays it happens. The sender wants to use the IP version 6, but the receiver does not understand the IP version 6. Okay, the tunneling does not work in this situation because the packet must be in the IP version 4 format to be understood by the receiver. In this case, the header must format must be totally changed through the header translation. Header translation. Let's see, the header of the IP version 6 packet is converted into the IP version 6 header. Then the header translation use the mapped address to translate IP version 6 address to the 4 address. So what we have to do? We have to change the address. We have to change the header format. Entire thing we have to change. What happened? Let's say if I have a sender and a receiver, I am sending one letter, and let's say in English, but the receiver is don't know what the English it is. So here somewhere in the middle, what we required a translation. What we require? Transmitter, middle one, through which that English language letter can be transferred, can be converted into that particular, let's say, Marathi or Hindi, and that can be understood by the receiver end. So this kind of things are available where if both the parties are different categories, so we have to have, let's say, Indian language, Chinese language, so that translation to be done. How it happens? Let's consider the host is the sender is what the host, which using, let's say, IP version 6. Then it's sending the packets in the regions with the IP version 6 terminologies, where the payload, that is message, is going to be encapsulated with the IP version 6. Then once it reaches to the somewhere, let's say the router, where that this router is having a router to the host which having, let's say, another region, and that is what the IP version 4 region. So this router must have the capability to translate this address and to understand these terminologies, so that this can pass to the receiver. So here in this router, what we have the capacity to understand that payload, and the payload is converted into that IP version 6 payload, encapsulated into IP version 4 header, and ultimately it is going to be received to that particular host, which is what the IP version 4. So how this transition and translation can be done? So there are some rules, standard rules are available of header translation. Let's take that rules, guys. These rules are very important. The rules are available. The very first rule: IP version 6 mapped address is changed to the IP version 4. So 6 address will be changed to the 4 address by extracting the rightmost 32 bits. So what we have, this right side 32 bit is extracted, because in IP version 6, rest left up side numbers are not that much important. The right side numbers are very important. That will be equivalent to IP version 4. Okay. Second rule: the value of IP version 6 priority field is discarded. There is no role of priority there, that will be discarded. Then the type service field in the IP version 4 is set to 0. In IP version 4, there are type services types, the two to three types of services for the priority and the other things also. That things to be set to be 0. Then checksum of the IP version 4 is calculated and inserted into the corresponding field, because if we are translating from the 6 to 4 and 4 to 6, we are required to have if kind of errors to be occur, and if the errors occur, that things to be set. Then IP version 6 flow label is ignored, because there is no role of full flow label in this particular process, because flow label is what? flow label refer to that flow table, and then it is going to be faster kind of things rather than consulting to the routing table. So this is ignored. Then capability extension header are converted to the option and inserted in the IP version 6 header. So some may have to be dropped. These steps also can be that must be applied. Then length of the IP version 4 header is calculated and inserted into the corresponding field. And the last step, guys, the total length of the IP version 4 packet is calculated and inserted into corresponding field. So these kind of things are available where the IP version 6 started, then IP version 6 header is calculated, then it reaches to the router. It having the header translation done over here. This router having a capability where entire IP version 6 format is going to be converted into IP version 6, because what we have here, there are some similar field but some different field. Here also there are some similar field but different field that need to be migrate so that the receiver can understand that entire thoroughly. So that setting to be done at this particular router end, guys. Okay, so these are the steps are available. So I hope, guys, these three methods and the figures have adopted from the Foragen books, that is fourth edition. And thank you so much. And in this lecture, what we have discussed about the three transition methodology: dual stack, tunneling, and header translation. Okay, so I hope, guys, this is okay with you. And like, if I go with the quickly, the header translation, what we have: sender having the 6, receiver having the 4. So this is what header translation. Tunneling, what we have: tunneling, both the ends having the IP version 6, but the tunnel is what the middle one is what the IP version 4, and the first one is what the dual stack. We have to maintain every both the stacks available with us so that we can understand thoroughly that particular package. So thank you